Question number 4. Show that y is equal to log x divided by x has maximum value at x is equal to e. Solution. We have y is equal to log x divided by x. So first find first derivative dy by dx, and by applying quotient theorem on the right hand side, and the quotient theorem was taking square on the denominator x square, this x will be as it is derivative of log x which is 1 by x minus then log of x will be as it is and derivative of denominator x which is 1. Now by simplifying, x will be cancelled out. We have 1 minus log x divided by x square. Now second derivative, again applying quotient theorem, x square whole square, x square will be as it is and derivative of 1 minus log of x which is minus 1 over x. Derivative of 1 will be 0 and derivative of log x is minus 1 over x. Minus, then 1 minus log x will be as it is and derivative of x square will be 2x. Now the second derivative will be, this will be cancelled out. We have minus x minus 2x and minus plus 2x log x divided by x4, and the second derivative will be minus 3x plus 2x log x divided by x4. So we have first derivative which is 1 minus log x divided by x square, and the second derivative minus 3x plus 2x log x divided by x4. We just have to show that this function has maximum value at x is equal to e. And by repeating the same procedure, we first find first derivative, then second derivative, and now put first derivative it equal to 0 and find the value of x. And that value of x must be equal to e, so that when we will put this x is equal to e in second derivative, that will return a value which shows that this one is a maximum value. And as we already know that function will be maximum when second derivative return a negative value. So for stationary points, put first derivative is equal to 0, and from this equation we will get the value of x. 1 minus log x divided by x square is equal to 0, and this implies actually numerator is equal to 0. 1 minus log x is equal to 0 and 1 is equal to log of x. This log of x will be as it is, and we can write log of e instead of 1 so that we can compare log and then find the value of x. So x is equal to e, and this one is because log of e is equal to 1, which is used in this place. Now put x is equal to e, this x is equal to e in our second derivative d2y by dx square. Then we get second derivative was to put x is equal to e in second derivative, we have minus 3 into e plus 2e divided by e4, and by simplifying we have minus e divided by e4 which is minus 1 over e cube, which is a negative value. So function or given function has a maximum value at x is equal to e, which shows that y is equal to log x divided by x has a maximum value at x is equal to e, because at this value second derivative returns a negative value, and we already know that if second derivative return a negative value, then the given function has a maximum value at that particular point, which is x is equal to e. Question 5. Show that y is equal to x raised to the power x has a minimum value at x is equal to 1 over e. Almost the same question. First we find first derivative, then second derivative, then put first derivative is equal to 0, and from that equation we get the value of x, which must be 1 over e, so that when we will put this x is equal to 1 over e in second derivative, that must return a positive value. so that the function will become minimum at x is equal to 1 over e. Now we start our question solution as given y is equal to x raised to the power x. As this one is an exponential function or a variable in exponent, so before taking derivative we must have to apply log on both sides. So log of y will become log x raised to the power x, and by applying the property of log, this log of y is equal to x into log of x. Now applying differentiation, we can mention it out here, differentiate with respect to x. Now applying derivative, the derivative of log of y is 1 over y, and then derivative of this y, which is dy by dx. And from here, this one is actually product of two terms, x and log of x. So applying derivative, that is x will be as it is, and derivative of log x, which is 1 by x, plus, and then log of x will be as it is, derivative of x will be 1. Now dy by dx is equal to, this y will be multiplied to the right hand side, which is 1 plus log x, by cancel out this x, and put the value of y, which is x raised to the power x, and 1 plus log of x. Now again differentiating, so differentiate again with respect to x. This will become a second derivative, which is d2y by dx square, and on right hand side again a product of two terms, x raised to the power x and 1 plus log x. This x raised to the power x will be as it is, and we have to take a derivative of second function, which is 1 plus log x, plus then 1 plus log x will be as it is, and derivative d by dx will be x raised to the power x. Now applying differentiation, x raised to the power x will be as it is, and derivative of 1 plus log x is 1 over x, plus this 1 plus log x will be as it is, and derivative of x raised to the power x. This one is actually d by dx of x raised to the power x, and x raised to the power x is actually dy by dx. This d by dx, or we can write d by dx x raised to the power x. And as x raised to the power x was equal to y, so we have actually dy by dx, and from 1 we may give a number, this one is 1, and from 1 dy by dx is x raised to the power x and 1 plus log of x. So the derivative dy by dx is x raised to the power x 1 plus log of x from 1, and now from this part d by dx x raised to the power x will become x raised to the power x 1 plus log x. We can write from 1. So the second derivative will become, by taking x raised to the power x as a common factor, we have 1 over x plus this 1 plus log x, and this 1 plus log x will become 1 plus log x whole square. Now for stationary points, put first derivative is equal to 0, and first derivative was x raised to the power x 1 plus log x is equal to 0. And if product of two terms is equal to 0, then either x raised to the power x will be 0 or 1 plus log x is equal to 0. But x raised to the power x can never be 0, so the only possibility is 1 plus log x is equal to 0, as x raised to the power x cannot be equal to 0. So from here we can write 1 as log of e plus log of x will be as it is equal to 0, and this log of x as it is and log of e will become minus log of e by shifting it to the right hand side, and log of x is equal to log e raised to the power minus 1. By applying the property of log, this minus 1 will become a power of e, and by comparison this implies that x is equal to e raised to the power minus 1, or x is equal to 1 over e. Now this x is equal to 1 over e will put into the second derivative. Put x is equal to 1 over e in our second derivative. We have d2y by dx square is equal to 1 over e raised to the power 1 over e, and 1 over 1 over e plus 1 plus log 1 over e whole square. We just put x is equal to 1 over e wherever the x was in second derivative. Now by simplifying, this 1 over e will remain same, 1 over e, and this will become e plus 1 plus log e raised to the power minus 1 whole square. Now by simplifying, this minus will come out before this log. By applying the property of log, this will become minus log of e whole square, and as log of e is equal to 1, so by replacing this log of e as 1, so 1 minus 1 will be cancelled out. We have this e into 1 over e raised to the power 1 over e, which is a positive number. This one is a positive number which is greater than 0. And as we already know that if second derivative return a positive value, then the given function is or has a maximum or a minimum value, so which shows y is equal to x raised to the power x has a minimum value at x is equal to 1 over e, which was required proof. So our required result is y is equal to x raised to the power x has a minimum value at x is equal to 1 over e.